So if we look at the basketball results, really all the results, if we look at the coefficient, we've got negative 5.2, essentially negative 5.2. This is for the 1 kilogram mass, and then negative 4.7 for that group. If we had perfect data, what would we expect that coefficient to be if it's just gravity driving the acceleration? What's that? Remember, it's half the acceleration. Negative 4.9 is what we would expect. We're actually pretty close, okay? And I will say the ones that I analyzed online, it's really nice to have a full-size computer screen to set the scale and pick the points, and I'll kind of share those with you in a second, the results I got, but I'm close, okay? So I think that's good. We expect this term to be half of g, and therefore it would be negative 4.9 because it's 1/2 AT squared. The middle term, I would suggest keeping it, and this group has 8.3 meters per second. This group has about 7.1 meters per second, and this group also had 8.3. It would be meters per second. What does that term represent in the motion? It's v0 times t. What's v0? The initial velocity, positive, right? Because it's upward. So this term is basically saying how fast did you throw it upward, okay? And then the last term, if you put the origin near the person's feet, we've got 2 meters, roughly 2 meters. This group, maybe you didn't set your origin. I think if you went back in, you'd be close to 2 meters. That's how far above the ground you are, right? So if you think of your feet and then meter sticks, 2 meters would be a little bit over your head probably, unless you're really tall. So that's your launch position. Your initial height was a little bit above the ground. So I'm actually really pleased with this. I think the fact that this is coming out pretty close to negative 4.9 for all 3 groups is really good. Tying that to the velocity graph, we said that this term is the initial velocity, and then check out the velocity graph. Look at where it starts, right at about 8.3, 8.4. Same thing here. They had initial velocity of about 7. It's a little bit below that. That would be where it starts, but it's not super different, okay? So I'm not too upset with that not matching perfectly. This group, again, the initial speed was around 8 meters per second, and this graph starts at about 8 meters per second. So we can start to see how those general models fit in with what we already know about the position equation, the velocity equation, and so on, okay? So I'm gonna try to show this on my screen. This is probably not the most efficient way to do this, but this was the bowling ball group. And one thing I had the advantage of was in going back and setting the scale. Go back here. I didn't realize, but you can zoom in pretty far, and that was hard to see on a laptop screen. So that might have been something that limited or added a little bit of error to our results. If you can zoom right in, you can get pretty close to the exact length of the meter stick in pixels. And my result here, I actually got negative 4.9 for that 1/2 AT squared coefficient. And in the velocity graph, the slope was negative 9.4. But one thing I noticed is the data points kind of looked better towards the middle of the graph. I get this kind of tail at the beginning and a tail at the end. So if I just highlighted the middle data points and do a linear fit, curve fit linear, now my slope is about negative 9.7. So again, I think probably your best data points in the velocity graph are near the middle. And if I play around with it, kind of changing which part I'm looking at. Look how close I am now. That's essentially negative 9.8 when I look at my kind of middle run of data. And I saw similar results for the other group. So this was basketball. My coefficient here, negative 4.9, which I expect. Over here again, if I drag to the middle data points, look at that, negative 9.8. So, and I bet if I even go here, that took it off a little bit. You can always play the game of which data points to keep, but if we go to kind of the middle part of the range, pretty good. So this was my 1 kilogram mass, negative 4.9, essentially. Same thing here. If I go to kind of my middle data points in the velocity graph, I'm getting closer to what I would expect. And I can game it just how I want probably, but you get the idea that we're seeing better results from this, and I think it's because of where the meter stick was. The meter stick being way up high in the video on the drop, I think there's just some distortion there, and it made the meter stick seem longer than it actually was. And when we have a kind of further backed up view, we'll get a better result. Okay, so I'm gonna go ahead and